Hello and welcome to another video on Mechanics 2020 A2 paper, question 2, and it's a constant acceleration and vectors question. You'll notice that they really are very predictable, the Mechanics A2 papers. Like, I think I've got the 5 categories they seem to ask questions on nailed down. I hope it always remains like that. There's nothing to say that they can't ask you AS questions, but I guess they're worried that some schools will have already done the AS paper last year, and so they try not to repeat it. I'm guessing. I don't know, but it seems quite samey so far for the last. We've had 2018 to 2022, so that's 5 sittings we've had. But anyway, let's get on with the question. So I know it's constant acceleration because it's told me the acceleration vector there, 4 minus 5, and it's not varying. The initial velocity is minus 2, 2. Cool. And I've got to find the velocity of p at t equals 2. So t equals 2, I've got to find v. Yeah, v is my question mark, if you like. So that shouldn't be too bad. V equals u plus at. And so v equals minus 2, 2 plus 4 minus 5 times 2. Now we can just work that out to give the answer as a vector. Minus 2 plus 8 is 6. 2 minus 10 is minus 8. And so the answer is, if you want to be paranoid and write it i's and j's at the end, 6i minus 8j meters per second. Yeah. Okay, so first one, so not too bad there. At time t equals 0, p passes through the origin. So it starts off at the origin. So if you are going to use that s equals, r0 plus ut plus a half at squared, that's good because what that's telling you is r0 is 0, 0, and so you can ignore it because it's starting at the origin. And so we've just got the more traditional s equals ut plus a half at squared. Okay, that's cool. At time t equals t, the particle passes through A. The position vector of A is lambda I minus 4.5j relative to O, where lambda is constant. So let's write down everything we've got here, because once again it's a SUVAT problem. Well, A is 4 minus 5, as we already wrote. U is minus 2, 2. Now this is for a different time, so I can't use t equals 2 and I can't use v is 6 minus 8. But I can use the fact that s or r, whatever you're calling it, the displacement from the origin, is lambda minus 4.5 and t equals t. Yeah, so what I can use is r equals ut plus a half at squared, but I'm going to have to use it twice. So if I look at the y components first, the j components, if you like, I've got minus 4.5 equals ut, so that's 2t, so capital T though. So just to make it clear here, I'm using s equals ut plus a half at squared. It's just that r and s are interchangeable in this topic, because it's a position of where it is. It's a position vector. So I'm using that. So I've got 2t minus 5, oh no, minus 2.5 t squared. Yeah, and this is going to give me an equation. So 0 equals 2.5 t squared minus 2t minus 4.5. And you can just use your calculator for that, can't you? So let's actually do that. I'm just going to use my calculator to kick out the solution to the quadratic. I suppose if I was doing it properly, I should double it, but I'll go on then, I'll do it properly. I would strongly advise you, though, to turn to the calculator and just get the calculator to solve this quadratic, but you're right, I shouldn't have that luxury on account of the fact that I can factorize a quadratic. Okay, so, well, let's see, can I factorize a quadratic? That's big talk. Minus 9 and plus 1. Okay, minus 9t plus 5t is minus 4t. It's looking good. So t is 9/5 because it's 5t minus 9 equals 0, so 5t is 9, so t is 9/5, or 1.8. Okay, there we go. C, hence find the value of lambda. Well, that's just a case of plugging it back into the top ones now. So I can say lambda equals minus 2t. I'll just write t for the moment. Minus, plus a half times by 4 times by t squared. Yeah, but I'm plugging in t is 1.8, and I'm going to find lambda. And so let's just plug it in. So I'm going to press 1.8 enter on my calculator, and then I can just press minus 2 times answer plus 2 times answer squared. Okay, and I'm getting 2.88 actually. which, doesn't sound that nicer answer, but that's the answer. Okay, hope you enjoyed the video. Hope it was useful. Keep up the hard work, and yeah, best of luck.